Hi again. Good afternoon. Good morning for me. Afternoon or evening for you guys. We're going to do Trigonometry McKeague Chapter 1, Section 5. This is the beginning of the trigonometric proofs. Go, oh, Mufasa. Kind of like, ooh. But it's the beginning of the proof, so it's not going to be that difficult once you get used to it, okay? And they're not very hard once you understand how it works. So first, let's go over to some of the examples. I'm just going to do the examples in the book, all 7 examples, and I am going to let you do all of the problems by yourself. It should be self-explanatory. If you look at the examples, understand how to do the examples, you should be able to do all the problems with a little bit of brute force, okay? First of all, you want to write example number 1 says find the tangent of theta in terms of sine only. Okay, we know that the tangent of theta is equal to the sine of the angle over the cosine of the angle. Got a little bit of problem here because we have cosine theta. So what we're going to do is, like I said in the previous section on Chapter 1, Section 4, you can see the Pythagorean theorem like crazy in trigonometric form. Sine squared of theta plus cosine squared of theta is equal to 1. You're going to try to solve for cosine theta right over here, okay? So we move the sine squared of theta, that term to the left side. Cosine squared of theta is equal to 1 minus sine squared of theta. That's pretty easy. You subtract sine squared of theta. To solve for cosine theta, you take the square root of the left side and the right side. On the left side, you get cosine of theta. The square root of this squared is itself is equal to, I'm going to use my marker, plus or minus equal to, sorry about that, equal to plus or minus the square root of 1 minus sine squared of theta. You cannot simplify the radical because there's 2 terms right over here inside the radical. So the answer becomes the sine of theta. I'm going to use a different marker for this. Let's use orange. Sine of theta over plus or minus the square root of 1 minus sine squared of theta. That's it. You can put the plus or minus theta to the outside, to the front. Doesn't really matter. You can put it in the denominator, middle, numerator. The preference is in the middle, guys, or on top, middle or top, not usually in the bottom. Example number 2. It says to write secant of theta, tangent of theta, in terms of sines and cosines only. Sine theta and cosine of theta only. From the last section, you should be able to see that the secant of theta is going to be 1 over cosine theta times, because the secant of theta, tangent theta means times right here. We're going to multiply that. So if you're not sure, just put a dot there. That way you know which one's being multiplied. Tangent theta is the sine of theta over the cosine of theta. We multiply straight across. 1 times the sine of theta is sine of theta. Cosine of theta times cosine of theta is cosine squared of theta. Don't forget we learned how to do denotations on the squared theta last time. So that's your answer. Let's do the next example. Example 3. We're going to add 1 over sine of theta plus 1 over cosine theta. We're going to simplify this expression. It's going to be a little bit complicated. Before we do this, let's do a little bit of review, guys. If I go 1/2 plus 1/3, I have to have common denominator here. The common denominator is 6, so I have to multiply the top and bottom by 3. That's fair, to make it 3 over 6. So the common denominator is equal to sine times cosine. I'm not sure if you can see that. So the common denominator is sine of theta times cosine of theta. So I have to multiply this by the cosine. I'm going to use short notation here. I have to multiply this by the sine, multiply it by the sine. So what I end up in the numerator is cosine of theta over cosine of theta times the sine of theta plus sine of theta in the numerator over cosine of theta times the sine of theta. Whoops. And we put them together in one single fraction now. So when they want you to do this in two fractions, they want you to put it at a single fraction. It's the sine of theta times the cosine of theta. Doesn't matter which one goes first. In the numerator, you have cosine of theta plus the sine of theta. We keep the denominator, we add the numerator, just like right over here, okay? We did example number 3. Let's do example number 4. It's a little bit tricky. It's not that tricky. Just a little bit. We're going to multiply sine of theta plus 2 times sine of theta minus 5. So sine of theta times 2, that quantity, that first factor, times sine of theta minus 5. Well, this is kind of like FOIL, isn't it? F-O-I-L, first, outer, inner, last. So I'm going to actually, usually the outer and the inner always combine. Not always, excuse me. Most of the time combine. So we're going to use FOIL, first, outer, inner, last. Use your fingers right over here. The sine of theta times the sine of theta. I'm going to label it too, just so you can see it better. The first is sine of theta times the first two terms. It's going to be sine squared of theta. Don't forget your notation, guys. Outer is sine of theta times negative 5. It's minus 5 sine of theta. And then inner is plus 2 times sine of theta plus 2 sine of theta. So don't forget, this is the outer and the inner. Okay, guys? And plus 2 times negative 5 is minus 10. So that's your F-O-I-L. And we always like to combine those. Usually they combine really nicely. Notice how I use the vertical format, guys, on this, okay? And that becomes sine squared of theta plus, minus 3 sine of theta. Minus 5 plus 2 is going to be minus 3 sine of theta, minus 10. Is that right? Let's see. Sine squared of theta minus 3 sine theta minus 10. Perfect. That's right. Example number 5. Now, this is where the trigonometric proof starts to come in. Example 5, 6, 7 is pretty. It's not that hard. We're going to start off really nice and easy for you guys. Example number 5. Show. Show means prove. So every time you see the word show, you go, ooh, Mufasa. No, it's not that bad. Show cosine of the angle times the tangent of the angle is equal to the sine of the angle. Show that's true. The cosine of the angle times the tangent of the angle is equal to sine of the angle. Most teachers will always make the left side or the right side, depending on whichever side is the most complex, and we're going to simplify it to the simple side of the expression. So this is the more complex one. You have to make sure that you get this guy to look like this guy. You cannot move anything around on this guy, because this guy is always going to be stagnant, not moving. Okay, so we're going to try to manipulate this really hard thing into this really simple thing. Pretty simple. Well, we know the cosine of the angle is the cosine of the angle. We know that the tangent of the angle is the sine of the angle. It's the ratio of the sine to the cosine of the angle. Question mark? Oh, look at that. It canceled. So you have sine of the angle is equal to sine of the angle on the right side. Check. QED. Quadratus demonstrator. So we have demonstrated that the left side is equal to the right side. So let's do something just a little bit harder. Okay? Example number 6 is just a little bit harder. Example 6. Prove. Oh, they use the correct word this time. Prove that sine of theta plus the cosine of the angle, opponent square, is equal to 1 plus 2 sine of the angle times the cosine of the angle. It seems to be, which seems to be the more complicated? Well, this looks to be the more complicated one, but actually this is the more complicated one because of this square right here. I'm going to highlight that square. This is the more complicated one. So we're going to try to make the left guy look like the right guy. How do you do that? We're going to have to forward this out. Sine of theta plus cosine of theta times sine of theta plus cosine of theta. That's what the square means. Equals, hopefully, it'll look like this guy on the right. Here, we have to forward this out, so put your forward hat on. Sine times sine is sine squared. Plus, sine theta times cosine theta is sine of theta times cosine of theta. Sine theta times cosine theta. I'm going to put sine of theta times cosine theta, same thing as cosine of theta times sine of theta. It's the same thing, so you can see it better. And then cosine theta plus cosine theta is cosine squared of theta equals what? I'm going to simplify this just a little bit. Sine squared of theta plus sine theta cosine theta plus another sine of theta cosine of theta. Get 2 sine of theta cosine of theta. Think about this a little bit. You have a coefficient 1 here. You get 2 of these terms plus cosine squared of theta equals what? Now I want you to think about this. See how we can make this guy look like this guy. Well, we have the 2 sine of theta cosine of theta right over here. Okay? And we got this 1 though. So how are we going to make it look like 1? We know something here. I want you to pause it and try to figure out what that is right there. You've seen it before, like 100 times maybe? No, not 100 times. Maybe 20, 30 times. We know that sine squared plus cosine squared equals 1. That equals 1 right there. Plus 2 sine of theta cosine of theta. Check. There it is right there. QED, quadrilateral demonstration. Okay, so, and thus we have demonstrated that this identity on the left is the same identity on the right. Okay, that was example number 6. Let's do a little bit of time. So we're actually going to do maybe example 7 and some of the other problems too. Got a little bit of time. Example 7. I'm going to simplify x squared plus 9, substituting let x equals 3 tangent of theta. Okay, so we're going to try to figure out if we let x equal 3 tangent of theta, we're going to try to simplify this expression without any x's. In other words, equals question mark. We're going to substitute x in there, so it's going to be 3 tangent of theta squared plus 9. What does that become? We expand this out. 3 tangent of theta times 3 tangent theta is equal to 9 tangent squared theta.